In March 1943, in the secret laboratories of the Kriegsmarine in Kiel, a terrifying discovery would forever change German understanding of why their submarines were being hunted like fish in an aquarium. What German naval engineers found in that captured equipment was not just advanced technology. It was the explanation for a massacre that was decimating the Reich's submarine elite. For months, veteran U-boat commanders reported the same nightmare. Sudden, precise attacks by Allied aircraft that seemed to appear out of nowhere, even on moonless nights with zero visibility. German submarines, which once dominated the Atlantic as invisible predators, now became easy prey for hunters who seemed to possess supernatural eyes. The answer to this deadly mystery lay in the hands of Vice-Admiral Erhard Maertens, Chief of German Naval Intelligence, when his team finally managed to fully analyze a captured British 3.8-inch centimetric radar. What they discovered would reveal not only Allied technological superiority, but also the terrible reality that German submarine warfare was being fought with obsolete equipment against an enemy who could see through the darkness. This technical investigation would not only explain the growing U-boat losses, but also demonstrate how a single technological innovation could completely transform the balance of power in the Atlantic, condemning hundreds of German submariners to a death they never understood until it was too late. The year 1943 marked the most brutal turning point of the Battle of the Atlantic. In the first months of that year, the Kriegsmarine lost 41 U-boats in March alone, a number that represented more submarines destroyed in a single month than in any previous period of the war. For German commanders, these numbers were not just statistics. They were evidence that something fundamental had changed in the nature of submarine warfare. Kapitän zur See Hans Rudolf Rösing, commander of the 2nd U-boat flotilla in Lorient, watched with growing alarm the reports arriving from his surviving commanders. "The planes find us even when we are surfaced on the darkest night," reported Korvettenkapitän Heinrich Lehmann-Willenbrock, a veteran of dozens of successful patrols. "It's as if they know exactly where we are." The reports were consistent and terrifying. Experienced U-boats, commanded by submarine warfare aces, were being surprised by Allied aircraft that attacked with surgical precision, even in weather conditions that should have made any visual detection impossible. The pattern was always the same. The first sign of danger was the roar of a bomber's engines already in a dive attack, followed by the devastating impact of depth charges or rockets. The situation became so critical that Gross Admiral Karl Dönitz himself, Supreme Commander of the German submarine fleet, ordered an urgent investigation. "Our best commanders are dying," he declared at an emergency meeting at Kriegsmarine headquarters. "Either we find out how the Allies are detecting us, or we lose the war in the Atlantic." The answer began to materialize when a British Vickers Wellington aircraft was shot down over German-occupied territory in February 1943. Among the smoking wreckage, German soldiers found something that initially appeared to be just another damaged radio set. However, when Luftwaffe technicians examined the device more closely, they realized it was something completely different from any radar technology they knew. The equipment was immediately transferred to the Telefunken laboratories in Berlin, where a team of engineers led by Dr. Wilhelm Runge began a detailed analysis. What they discovered left them perplexed. It was a radar system operating at a frequency of 3.8 inches, much higher than anything the Germans had managed to develop operationally. German radar technology, although advanced in many respects, was limited to much lower frequencies, typically in the 5-foot range. This limitation was not just technical, it was fundamental to the system's effectiveness. Lower frequency radars had a greater range, but their accuracy was limited, and they were easily detectable by the German radar warning receivers installed on U-boats. The captured centimetric radar represented a technological leap that the Germans had not anticipated. Operating at much higher frequencies, this system offered dramatically superior resolution, and more importantly, was completely invisible to existing German radar detectors. For German submariners, it was as if their enemies had developed the ability to see through walls, while they remained completely blind to this new threat. When the captured equipment finally arrived at the naval laboratories in Kiel, Vice-Admiral Erhard Maertens immediately understood the devastating implications of the discovery. Maertens, an experienced intelligence officer who had served in World War I, possessed the rare combination of technical knowledge and strategic insight necessary to fully assess the significance of this technology. The analysis revealed that centimetric radar not only detected surfaced U-boats with extraordinary precision, but could also do so at distances that allowed for complete surprise attacks. While German 5-foot radars could detect large targets at considerable distances, their resolution was insufficient to distinguish between a submarine and other objects on the sea surface, especially in rough seas. The British 3.8-inch radar, on the other hand, offered sufficient resolution to clearly identify the characteristic silhouette of a U-boat, even amidst the waves. More crucially, its high frequency meant that the radar beam was much narrower and more focused, allowing Allied aircraft to locate submarines with enough precision for effective night attacks. Maertens calculated that an aircraft equipped with this radar could detect a surfaced U-boat at a distance of approximately 11.5 miles, giving the pilot enough time to position for an optimized attack before the submarine crew even suspected its presence. For submarines that relied on darkness to recharge batteries and ventilate stale air, this detection capability represented a death sentence. The most shocking revelation of Maertens' analysis was not just the technical superiority of Allied radar, but the understanding that the Germans had completely underestimated the speed of enemy technological development. German engineers had assumed that the Allies faced the same technical limitations they themselves encountered in developing high-frequency radars. Cavity magnetron technology, which made efficient operation at centimetric frequencies possible, had been a closely guarded British secret. When the Germans finally understood the principles behind this technology, they realized they were at least 2 years behind in developing equivalent systems. This delay was not just inconvenient, it was fatal for hundreds of German submariners. Korvettenkapitän Werner Henke, commander of U-515 and one of the Kriegsmarine's most respected aces, had reported months earlier a typical encounter with this new threat. "We were surfaced on a moonless night, with virtually zero visibility due to fog. There was no possibility of visual detection. Suddenly, a Wellington emerged from the darkness already in a dive attack, as if it had known our exact position for miles. Henke managed to dive in time to avoid critical damage, but many of his colleagues were not so lucky. Henke's U-boat was one of the few that survived to report what it was like to be hunted by an enemy who could see through the night. Most other submarines simply disappeared, their fates known only by the wreckage and oil slicks that occasionally reached European shores. The detailed technical analysis revealed even more disturbing aspects of Allied superiority. Centimetric radar not only detected U-boats with lethal precision, but also allowed Allied aircraft to coordinate multiple attacks with devastating efficiency. The system could track several targets simultaneously, allowing a single plane to direct others to optimized attack positions. German engineers discovered that the captured radar possessed signal processing capabilities that allowed it to distinguish between different types of naval targets. A surfaced submarine produced a characteristic radar signature that was easily distinguishable from merchant ships, destroyers, or even floating debris. This discrimination capability meant that Allied aircraft could identify U-boats with virtual certainty, eliminating false alarms that wasted time and fuel. Even more alarming was the discovery that the system could operate effectively even in adverse weather conditions that traditionally offered protection to German submarines. Storms, dense fog, and heavy rain, conditions that U-boat commanders had learned to use as natural cover, were virtually transparent to centimetric radar. Kapitänleutnant Reinhard Hartigan, a veteran of successful attacks against the American coast, described the new reality in his final report. "There is no longer any hiding place in the ocean. The enemy sees us when we cannot see them, hears us when we are silent, and finds us when we believe ourselves invisible. It is like fighting ghosts who possess eagle eyes." Maertens' investigation also revealed the sophisticated coordination between different Allied systems that multiplied the effectiveness of centimetric radar. Aircraft equipped with this radar did not operate in isolation. They were part of an integrated detection network that included escort ships, coastal stations, and other aircraft, all sharing real-time information through advanced communication systems. This coordination allowed the Allies to create a hunting net that covered vast areas of the Atlantic. When a U-boat was detected by an aircraft, its position was immediately transmitted to other units in the area, creating a coordinated response that made it almost impossible for the submarine to escape. The Germans discovered that the Allies had developed specific tactics to exploit the capabilities of centimetric radar. A particularly effective tactic involved aircraft flying in coordinated search patterns, with each plane covering a specific swath of the ocean. When a U-boat was detected, the aircraft that made the detection did not attack immediately. Instead, it coordinated with other aircraft to encircle the submarine, eliminating escape routes and ensuring that at least one aircraft was in an optimal position for a lethal attack. Fregattenkapitän Günther Hessler, Dönitz's son-in-law and an experienced tactical analyst, observed that this coordination represented a fundamental evolution in anti-submarine warfare. They are no longer hunting our U-boats individually. They have created a war machine that treats each submarine as part of a mathematical problem to be solved through precise coordination and superior technology. The most devastating discovery of the analysis was the understanding that centimetric radar rendered many of the fundamental tactics of German submarine warfare obsolete. Dönitz's Wolfpack strategy, which relied on multiple U-boats coordinating attacks against Allied convoys, became not only ineffective, but suicidal when facing aircraft equipped with centimetric radar. Traditionally, U-boats operated in groups, communicating by radio to coordinate attacks. This tactic had been extremely effective in the early years of the war, when the Allies had limited ability to detect submerged or surfaced submarines at night. However, centimetric radar transformed every radio transmission into a beacon that guided lethal hunters directly to the submarines. Worse still, the concentration of multiple U-boats in a relatively small area created a rich target for aircraft equipped with centimetric radar. A single aircraft could detect several submarines simultaneously and coordinate attacks that resulted in the destruction of multiple U-boats within hours. The tactic that had made the Kriegsmarine so effective had now become its greatest vulnerability. Kapitän zur See Viktor Uhrn, one of the most experienced commanders in the German submarine force, summarized the situation in a grim report. "Our tactics were developed for a blind enemy. Now we face an adversary who can see our every move, while we remain blind. It is no longer a matter of skill or courage. It is a matter of survival against impossible odds." Maertens' analysis also revealed that the Germans had severely underestimated the Allied production capacity for centimetric radar systems. Initially, German commanders expected this technology to be limited to a few experimental aircraft or elite units. The reality was far more alarming. The Allies were mass-producing these systems and rapidly equipping their entire fleet of anti-submarine aircraft. Intelligence data collected through interrogations of Allied prisoners and analysis of captured equipment indicated that the British and Americans had established dedicated production lines specifically for centimetric radars. Factories in England and the United States were producing hundreds of these systems monthly, with production steadily increasing. This mass production capability meant that the Allied technological advantage was not temporary or limited. Each passing month saw more Allied aircraft equipped with centimetric radar patrolling the Atlantic, creating an increasingly dense and lethal detection network. For German U-boats, this meant that the safe areas of the ocean were rapidly shrinking. Conter-Admiral Eberhard Gott, Chief of Operations of the submarine force, calculated that, at the current rate of Allied production, the entire North Atlantic would be under effective centimetric radar coverage by the end of 1943. This projection was not just a technical estimate, it was a prediction that German submarine warfare was doomed unless a solution was found quickly. While Maertens and his team analyzed the technical implications of centimetric radar, Kriegsmarine operational commanders faced the brutal reality of this new threat at sea. Kapitän Lieutenant Wolfgang Luth, one of Germany's most decorated U-boat commanders, reported an experience that would become sadly common among surviving German submariners. During a patrol in the central Atlantic in April 1943, Luth's U-boat was attacked 3 times in a single night by aircraft that seemed to know its exact position. Every time we surfaced to recharge batteries, they were there, Luth reported. It didn't matter if we changed course, if we zigzagged, or if we chose areas with adverse weather conditions. They always found us. Luth's experience illustrated how centimetric radar had fundamentally transformed the nature of submarine warfare. Submarines that relied on the surface to recharge batteries, ventilate air, and travel at high speed now faced constant attacks whenever they surfaced. This continuous pressure forced U-boats to remain submerged for increasingly longer periods, drastically reducing their operational effectiveness. Submerged, German U-boats were limited to speeds of only 4 to 6 knots and had severely restricted endurance. They could neither effectively pursue convoys nor escape surface hunters. Centimetric radar had effectively imprisoned German submarines underwater, transforming them from agile predators into slow, vulnerable targets. The discovery of centimetric radar also forced the Germans to confront an even more disturbing reality. They had lost the technological race more decisively than they imagined. Technical analysis revealed that the Allies not only possessed superior radar, but had also developed effective countermeasures against existing German systems. The German radar detectors installed on U-boats, known as Metox and later Naxos, were completely useless against centimetric radar. These devices had been designed to detect known Allied radar frequencies, but the new technology operated at frequencies completely outside their detection range. For U-boat crews, this meant that their early warning systems were worse than useless. They created a false sense of security. Even more alarming was the discovery that the Allies had developed techniques to use the Germans' own detectors against them. Some Allied radars could detect the emissions from German Metox devices, turning them into beacons that revealed the U-boats' positions. German submariners discovered that their own protective equipment was betraying them. Oberleutnant Surse Herbert Werner, a survivor of multiple patrols, described the paranoia that developed among the crews. We no longer knew what to trust. Our radar detectors were useless, our communication equipment betrayed us, and our own navigation systems seemed to guide the enemy to us. It was as if every piece of technology on the submarine had turned against us. Maertens' analysis also revealed that centimetric radar was only one part of an integrated anti-submarine warfare system that the Allies had developed. Radar technology was coordinated with advanced communication systems, precise navigation equipment, and weapons specifically designed for aerial attacks against submarines. Allied aircraft equipped with centimetric radar also carried a new generation of anti-submarine weapons that maximized the effectiveness of radar-guided attacks. Unguided rockets, depth charges with proximity fuses, and even air-launched torpedoes created a lethal arsenal that could destroy a U-boat with a single successful attack. The coordination between radar detection and specialized weaponry meant that Allied aircraft no longer needed multiple attacks to destroy a submarine. Centimetric radar allowed for precise positioning for a lethal first strike, eliminating the opportunity for the U-boat to dive or maneuver defensively. This one attack, one kill effectiveness transformed every encounter with Allied aircraft into an almost certain death sentence. Kapitän Lieutenant Horst von Schroeder, commander of U-123, survived one of these coordinated attacks and described the experience. It was like being struck by lightning. There was no warning, no opportunity for defense. One moment we were sailing in apparent safety. The next we were struggling to keep the submarine afloat, as water poured through holes that seemed to have been made by giant hammers. As the analysis progressed, Maertens began to understand that centimetric radar represented more than a temporary technological advantage. It indicated a fundamental shift in the industrial and scientific capacity of the Allies. The speed with which this technology had been developed, mass-produced, and operationally implemented demonstrated a level of coordination between science, industry, and armed forces that the Germans had underestimated. The British had managed to mobilize their best scientists, engineers, and technicians in a coordinated effort that produced not only centimetric radar, but an entire family of related technologies. This total scientific mobilization contrasted sharply with the German effort, which was fragmented among different agencies, military services, and conflicting priorities. The most demoralizing discovery was that the Germans possessed the theoretical knowledge necessary to develop centimetric radar, but had failed to transform this knowledge into effective operational systems. German scientists like Rudolf Kuhnhold had conducted pioneering research in radar technology, but this research never received the priority and resources needed for rapid development. Professor Wilhelm Runge, who led the technical analysis of the captured radar, admitted in his report, "We knew the principles. We understood the physics, but they turned science into weapons while we were still debating priorities." This is not just a technological defeat, it is a defeat of organization and determination. The operational reality of centimetric radar's superiority became evident through the increasingly desperate reports from U-boat commanders at sea. Korvettenkapitän Reinhard Suren, commander of U-564 and a veteran of dozens of successful patrols, sent a report that captured the new reality of submarine warfare. The ocean no longer offers refuge. Every surfacing is a deadly risk. We are being hunted by enemies who see us when we are invisible. The numbers confirmed this brutal new reality. In May 1943, the Kriegsmarine lost 41 U-boats, more submarines than in any previous month of the war. These losses were not randomly distributed. They were concentrated in areas where Allied aircraft equipped with centimetric radar operated most intensively. The correlation between centimetric radar coverage and U-boat losses was statistically undeniable. Even more alarming was the discovery that losses were increasing exponentially, not linearly. Each month saw more Allied aircraft equipped with centimetric radar, creating a density of coverage that made U-boat survival increasingly unlikely. Kriegsmarine mathematicians calculated that, if the trend continued, the operational life expectancy of a U-boat would fall to less than 2 patrols. Fregattenkapitän Günther Hessler, analyzing the operational data, reached a grim conclusion. We are no longer losing a war. We are witnessing the systematic extermination of our submarine force. Centimetric radar has transformed our submarines from hunters into prey, and prey that cannot hide. Maertens' analysis also revealed that the Germans had underestimated the Allied ability to adapt tactics to maximize the effectiveness of centimetric radar. The Allies not only possessed superior technology, they had also developed sophisticated operational doctrines that fully exploited the capabilities of this technology. A particularly effective tactic involved using centimetric radar-equipped aircraft as scouts for larger hunting groups. These aircraft flew in systematic search patterns, detecting U-boats at long distances and then coordinating attacks by multiple aircraft. This coordination allowed for simultaneous attacks from different directions, eliminating any possibility of escape for the submarine. The Allies had also developed specific night tactics that exploited the U-boat's inability to detect centimetric radar. Aircraft attacked during the darkest hours of the night, when submarines traditionally felt safest to surface. These night attacks were particularly devastating because they denied U-boats any possibility of early visual detection. Kapitänleutnant Erich Topp, one of the Kriegsmarine's most respected aces, described one of these coordinated attacks. They came from 3 directions simultaneously, as if they had rehearsed the attack for weeks. There was nowhere to run, no way to dive in time. It was an execution, not a combat. As the investigation deepened, Maertens discovered that centimetric radar had created a devastating psychological effect on U-boat crews that was almost as destructive as its tactical impact. Experienced submariners, who had faced destroyers, corvettes, and aircraft with courage and skill, now reported levels of stress and anxiety that compromised their operational effectiveness. The inability to detect the threat of centimetric radar created constant paranoia among the crews. Every surfacing to recharge batteries or ventilate the submarine became an exercise in terror, with lookouts scrutinizing seemingly empty skies for invisible threats. The knowledge that enemy aircraft could be observing them without any indication created unbearable psychological tension. Kriegsmarine medical reports documented a dramatic increase in cases of combat fatigue and war neurosis among submariners. Crews who previously completed 60-90-day patrols with high morale now showed signs of psychological collapse after just a few weeks at sea. The certainty that they were being hunted by an invisible enemy eroded the crew's confidence and cohesion. Oberarzt Dr. Heinrich Buchting, the naval doctor responsible for the mental health of submariners, reported, "Our men do not fear death in honest combat. They fear invisible death, the attack that comes without warning from an enemy they cannot see or detect. This fear is destroying morale more effectively than any weapon." The most shocking discovery of Maertens' investigation was the understanding that the Germans possessed no quick technological answer to centimetric radar. While German engineers could now understand the principles behind Allied technology, developing effective countermeasures would require years of research and development. Time the Kriegsmarine simply did not have. German attempts to develop detectors for centimetric radar faced fundamental technical challenges. The high frequencies used by centimetric radar required specialized electronic components that German industry was not equipped to mass produce. Even if prototypes worked, production on a scale sufficient to equip the entire U-boat fleet would take at least 2 years. Even more disheartening was the discovery that the Allies were already developing the next generation of radar technology. Fragmentary intelligence suggested that even more advanced systems were being tested, including radars that could detect submerged submarines in shallow waters. The technological race was not just lost, it was accelerating in favor of the Allies. Dr. Hans Plendl, director of Luftwaffe radar research, admitted at a confidential meeting, "We are chasing a target that moves faster than our ability to catch it. When we develop countermeasures for the current centimetric radar, they will already have systems that will render our countermeasures obsolete." Operational analysis revealed that centimetric radar had created death zones in the Atlantic where U-boat survival was statistically impossible. These zones corresponded exactly to the areas of highest coverage by Allied aircraft equipped with centimetric radar, creating a map of death that German commanders could see but could not avoid. Traditional U-boat transit routes, which had been carefully developed to avoid known Allied patrols, became deadly traps. Submarines following these safe routes were detected and attacked with predictable regularity. The predictability of losses was perhaps the most demoralizing aspect of the new reality. German commanders could calculate with mathematical precision how many U-boats would be lost in each operation. Conter-Admiral Eberhard Gott developed statistical models that showed the direct correlation between centimetric radar coverage density and U-boat losses. These models predicted that areas with full centimetric radar coverage would have U-boat loss rates exceeding 90% per patrol. These were not estimates. They were predictions based on actual operational data. The mathematics were relentless and inescapable. Every U-boat entering areas of high centimetric radar coverage had less than a 10% chance of returning. For commanders who had sent hundreds of submarines to sea, this statistic represented the condemnation of thousands of German submariners to an almost certain death. As the investigation approached its conclusions, Maertens faced the most difficult task of his career, communicating to the Kriegsmarine leaders that German submarine warfare was effectively lost. Centimetric radar was not just a temporary technological advantage. It was a fundamental shift in the balance of power that made the continuation of German submarine warfare an exercise in bloody futility. The numbers were undeniable. In 1942, the Kriegsmarine had lost 87 U-boats throughout the year. In just the first 5 months of 1943, they had already lost 96 submarines. The loss rate was accelerating exponentially, while the effectiveness of German attacks against Allied shipping was drastically decreasing. Centimetric radar had completely reversed the equation of submarine warfare. Even more devastating was the projection that losses would continue to increase as more Allied aircraft were equipped with centimetric radar. Maertens' mathematical models predicted that, by the end of 1943, the Kriegsmarine would be losing U-boats faster than it could build them, even with wartime production running at maximum capacity. The conclusion was inescapable. Centimetric radar had made German submarine warfare unsustainable. Continuing to send U-boats into the Atlantic would be equivalent to murdering their own crews without any possibility of strategic success. Technology had decided the Battle of the Atlantic before German commanders even understood they were fighting a technological war. In June 1943, Maertens presented his final conclusions to the Kriegsmarine High Command at a meeting that would forever change German naval strategy. His presentation, based on months of rigorous technical analysis and undeniable operational data, painted a grim picture of the technological reality Germany faced. Allied centimetric radar represents more than a technological advantage, Maertens declared. It represents a fundamental shift in the nature of naval warfare. Our U-boats, which were designed to operate as invisible predators, are now visible targets for hunters with perfect electronic eyes. The presentation included practical demonstrations of the captured equipment, showing the officers present exactly how centimetric radar detected submarines with lethal precision. For many of the officers present, this was the first time they fully understood the technological superiority they faced. The demonstration was followed by a prolonged, somber silence. Maertens concluded his presentation with a recommendation that shocked his listeners. The Kriegsmarine should consider the temporary withdrawal of U-boats from areas of highest centimetric radar coverage until effective countermeasures could be developed. This recommendation amounted to admitting defeat in the Battle of the Atlantic, an admission few German commanders were prepared to make. The High Command's response to Maertens's presentation revealed the difficulty of accepting such a complete technological defeat. Vice-Admiral Erhard, confronted with irrefutable evidence of centimetric radar's superiority, initially resisted the implications of the findings. "Our submariners are the best in the world," he declared. "They will find ways to overcome this enemy technology." However, operational data continued to confirm Maertens' analyses. Each week brought reports of more U-boats lost to precise and coordinated aerial attacks. The correlation between centimetric radar coverage and submarine losses became so clear that even the most optimistic commanders could no longer deny it. The final decision came in July 1943, when Erhard ordered the temporary withdrawal of U-boats from the North Atlantic, the first time in the war that the Kriegsmarine publicly admitted that an area of the ocean had become inaccessible to German submarines. This decision marked the effective end of the Battle of the Atlantic as a serious contest between German and Allied forces. The discovery of centimetric radar and its implications fundamentally transformed German understanding of the nature of modern warfare. Maertens's analysis had revealed that World War II was not just a conflict of strategy, courage, and resources. It was a war of technology where scientific superiority could determine the outcome regardless of other factors. This revelation forced a complete reevaluation of German research and development priorities. Resources previously dedicated to prestige projects or miracle weapons were redirected to basic research in electronics and radar technology. However, this shift in priorities came too late to affect the outcome of submarine warfare. The bitterest lesson of Maertens' investigation was the understanding that Germany had lost the technological war not due to a lack of brilliant scientists or theoretical knowledge, but due to organizational and prioritization failures. The Allies had managed to mobilize their scientific and industrial resources more effectively, transforming research into operational weapons with a speed the Germans could not match. Professor Werner Heisenberg, one of Germany's leading physicists, observed, "We possessed the knowledge to develop centimetric radar. We understood the physical principles involved, but they turned physics into victory while we were still debating theories." Science without practical application is just expensive philosophy. In the months following Maertens' presentation, the reality of centimetric radar's superiority continued to manifest through devastating U-boat losses. Even with modified tactics and alternative routes, German submarines continued to be detected and destroyed with predictable regularity. Technology had created an advantage that transcended traditional tactics and strategies. The few U-boats that managed to survive patrols in areas of centimetric radar coverage returned with traumatized crews and reports that confirmed Maertens' analysis. Korvettenkapitän Heinrich Lehmann-Willenbrock, after his last patrol, reported, "We are no longer fighting a naval war. We are participating in a scientific experiment where we are the laboratory rats." The effectiveness of centimetric radar also had strategic consequences that extended far beyond submarine warfare. The Allied ability to detect and destroy U-boats with lethal precision freed up enormous naval resources that were previously dedicated to convoy escort. These resources could be redirected to offensive operations, accelerating the overall pace of the war. More importantly, the defeat of the German submarine threat ensured that American supplies continued to flow to Great Britain, and subsequently, for the preparation of the invasion of Europe. Centimetric radar not only won the Battle of the Atlantic, it made Allied victory in Western Europe possible. Maertens's final analysis of centimetric radar revealed a truth that transcended purely military considerations. World War II had become a competition between entire scientific and industrial systems, not just between armed forces. The ability to transform scientific research into operational military advantage had become the determining factor for victory. Centimetric radar represented the triumph of a technological development model that integrated university research, industrial development, and military needs into a coordinated system. The Allies had managed to create an innovation machine that produced technological solutions at the speed required by modern warfare. For Germany, the discovery of centimetric radar marked the moment when the military leadership understood that they had lost not just a battle or a campaign, but a fundamental competition of technological capability. This understanding changed the nature of the German war from a quest for victory to a struggle for survival. Maertens' investigation had begun as an attempt to explain growing operational losses. It ended as a revelation that modern warfare would be decided by laboratories and factories as much as by battlefields. Centimetric radar was not just a weapon. It was the symbol of a new era where scientific superiority would determine the fate of nations.